So before solving this problem, we must know that the Pauli spin matrices are sigma x is equal to 0, 1, 1, 0, sigma y is equal to 0, negative iota, positive iota, 0, and sigma z is equal to 1, 0, 0, negative 1. Now, the second thing that we must know is that so S sub x is equal to h over 2 x sigma x, and sy is equal to divided by 2 sigma y, and s sub z is equal to by 2 divided by z. So the last thing that we must remember before solving this question is that A operator, B operator is equal to A, B minus B, A. So for part A, what we are going to do here. So for part A, first of all, we have that S x S y is equal to S x S y minus S y S x. Now the next step is that square divided by 4, 0, 1, 1, 0 times 0, negative iota, positive iota, 0 minus 0, negative iota, positive iota, 0 times 0, 1, 1, 0. So when we'll simplify it, we'll get that square divided by 4, negative iota, 0, 0. Sorry, positive iota, 0, 0. Negative iota minus negative iota, 0, 0, positive iota. And when we simplify this equation, we'll get that divided by 4, 2 iota, 0, 0, negative 2 iota, and round brackets. So this is equal to iota h times divided by 2, 1, 0, 0, negative 1. And this becomes is SZ, that is basically Sx, Sy, that is equal to iota h s z. So for part 2, what we are going to do, so for part 2, we have that Sy Sz is equal to Sy Sz minus Sz Sy. So we are going to do it. We are going to solve it the same like the above one, and we'll get that square divided by 4, 0, 2 iota, positive 2 iota, 0 is equal to iota times divided by 2 times 0, 1, 1, 0, and that is from here we can write that iota hsx. This implies that sy sz is equal to iota ihx sx. So for part 3, what we are going to do over here is that we have sz sx. So same as the above one, we'll write it as sz sx minus xs sx times sz. So what we are going to do over here, are going to solve it just like we solved the above two parts. So this will yield that divided by 4 times 0 to negative 2 0, and this is equal to iota h times a divided by 2, and over here we are left with 0 iota 0, and this is equal to iota h s y. So we can write that s sub z, s sub x is equal to iota h s y. So from here we can conclude that s I s j, where ij can be equal to any x y z. So this is equal to iota. So from the above three parts we conclude that s sub I s j is equal to iota element I j k s sub k. Fine. So now we're going to solve part B. So for part B, part 1, we have that sigma x is equal to 0, 1, 1, 0 times 0, 1, 1, 0. And this is basically equal to 1, 0, 0, 1. That is equal to 1. What we are going to do next, we have sigma y that is equal to 0, negative iota, positive iota, 0 times 0, negative iota, positive iota, 0, and that is equal to 1, 0, 0, 1. This is equal to 1. Lastly, we have sigma z times sigma z. So this is equal to 1, 0, 0, negative 1 times 1, 0, 0, negative 1. And this is equal to 1, 0, 0, 1. This is equal to 1. So from here we can conclude that sigma x times sigma x is equal to sigma y times sigma y, that is equal to sigma z times sigma z. Now what we are going to do for part 2. So for part 2, what we are going to do, we are going to multiply sigma x with sigma y. So we get that 0, 1, 1, 0 times 0, negative iota, positive iota, 0 is equal to iota 1, 0, 0, negative 1. So this is equal to iota sigma z. So similarly, we are going to do it for sigma y, sigma z, and this would be equal to iota 0, 1, 1, 0. That is equal to iota sigma x. Next, we are going to multiply sigma z with sigma x. So when we solve it just like we solved the first one, we'll get that it is equal to iota 0, negative iota, positive iota, 0, and this is equal to iota sigma y. So what are we going to do next? So the next is to multiply sigma y with sigma x. So we'll get that negative iota 0, 1, 1, 0. This is equal to negative iota sigma z. Next, we are going to multiply sigma x with sigma z, and we will get that negative iota 0, negative iota, positive iota 0, and that is equal to negative iota sigma y. And lastly, we have sigma, sorry, over here we get that. Okay, okay, fine. we have that. So the last thing that we have is that sigma z times sigma y is equal to negative iota 0, 1, 1, 0. That is equal to negative iota sigma x. So from here we can deal that sigma j times sigma k is equal to iota. For all we have that I j k I j k I j k, and it is multiplied with sigma L for all j is not equal to k, and this implies that I'm running out of space over here, so I'm going to write it over here. So this implies that sigma j times sigma k is equal to j k. So now if for all j is equal to k, so this would imply that sigma j times sigma k is equal to del j k plus summation L element I j k sigma L. So now this I j k can be equal to x y z or anything like that. So this is your solution.